Hello, welcome to the Erasmus Plus project CHAISE, Module 2, Regulation, Legal Aspects and Governance of Blockchain Systems. In this fifth lecture, we focus on the blockchain governance, identifying the rules controlling the way actors of a blockchain ecosystem interact and the way decisions are taken in such a distributed ecosystem. This lecture takes advantage of the knowledge provided in the previous lecture, namely defining the blockchain context in Lecture 1. Lecture 2 has provided some governance background, and the organization of the blockchain ecosystem has been stated in Lecture 3. As stated in the CHAISE project, after attending this lecture, you will be able to explain implications of the blockchain technology for governments, policymakers, law professionals, regulators, and society, and illustrate the impact of the blockchain governance on policy effectiveness. You will also be able to take responsibility when deciding about blockchain, cryptocurrencies, and use of smart contracts, thanks to a better understanding of the way the blockchain ecosystem is organized. You can also participate in discussion regarding blockchain technology impact and blockchain governance decisions. These skills are based on some knowledge related to the implications of blockchain technology for society, regulators, policymakers, governments, and law professionals. Governing complex systems as blockchain systems is not so obvious. This requires defining what is really addressed by the governance process, the different kinds of decisions, and the way these decisions are controlled. According to your best knowledge, can you define precisely the perimeter addressed by the blockchain governance rules? Which kinds of decisions are concerned? Simple ones? Complex ones? Is there a unique decision organization? How are decision processes implemented? Are they fully automatized? Are they manual? So, to sum up, can you define who decide what to fit which goal impacting which system? Let's think and brainstorm together. Based on your best knowledge on blockchain, are all blockchain systems from blockchain 1.0 to blockchain 4.0 similar? Are the perimeters similar? Should you refer to the blockchain project, including usage, or only to the blockchain technology? Based on Lecture 3, Ecosystem Description, who are the actors? What are their roles? Can you identify some rules allowing them to interact together in a consistent way? Focusing on decisions. Which kinds of decisions are controlled? Operational? Tactical? Strategic? Which kind of decisions are operational decisions in a blockchain project? And what means blockchain operation? Is it a very short term? Is it related to technology? To the blockchain project? What is behind the tactical decisions? Which kind of risks how can you state that the blockchain system will remain working according to a midterm vision? What is the strategy for the blockchain project? Why is it developed? For what? Does this impact the strategy and the governance strategy? Who are key actors of the blockchain ecosystem and who can decide? Why an actor should decide or should to participate to a decision? Can you explain it? Should decision processes be on-chain, or fully automated, and registered as immutable decisions? Or should they be taken off-chain, integrating human decision? Understanding and setting a blockchain governance is not so simple as you can see. In this lecture, you will learn how to characterize blockchain governance challenges and requirements, and identify key decision and governance organizations. You will also learn the way on-chain and off-chain governance rules are organized thanks to a blockchain governance framework. To sum up, this lecture addresses different learning objectives regarding governance and decision organization. Focusing on blockchain context, you will get the necessary knowledge to identify key requirements and the decision system organization. We will compare centralized and decentralized organization for blockchain governance rules and processes regarding operational, tactical, and strategical decisions. This includes on-chain and off-chain governance rules introduced to govern the distributed ecosystem and to manage the technological side of the blockchain system. A blockchain governance framework providing a guideline to set or analyze governance system organization will also be presented. According to these learning objectives, this lecture is organized into three main parts. We will first introduce the blockchain governance organization, identifying key requirements and presenting the centralized or decentralized decision strategies. Then, we will focus on the blockchain governance principles, identifying on-chain and off-chain processes before characterizing operational, tactical, and strategical governance processes and organizations through the presentation of a blockchain governance framework. First of all, let's introduce governance and its multiple definitions. As presented in Lecture 2, there are different definitions associated to the governance perimeter. Organizations, technical and socio-technical systems, enterprises. There's no single decision for governance perimeter. For all cases, governance means setting rules and processes to control interactions between entities composing the global system. These decision rules are set to meet the system's objectives. As far as enterprises and other socio-economic organizations are concerned, these decisions also include performance management so that strategy adjustment can be made. As a decision support system, the governance system manages interactions of members of the ecosystem, and it sets clear decisions regarding the ecosystem development strategy as well as more operational decisions. Focusing on the way decisions are managed, let's come back to the decision definition. According to Cambridge Dictionary, a decision is a choice you make about something after thinking about several possibilities. This means that a decision is associated to a precise scope, including the decision time frame, the operation, tactic, or strategic vision, and the decision is also made according to a decision context. As far as operation decisions are concerned, decision rules can be set to support a semi-automated decision process. Each decision rule is described precisely, defining the decision workflow to support the decision process. This workflow defines precisely the actors involved in the different tasks, such as preparing the decision or approving it. We can note that somebody can prepare, but may not take part in the approval process. And on the other hand, people who has to approve a decision need to get all the necessary information, and gathering this necessary information, this can be an activity done by someone else. For short, a generic decision process encompasses three main steps: decision preparation, decision approval, and decision deployment. The decision preparation defines the different choices to face a given event or context and the associated time frame. Of course, depending on the decision time frame, it may be more or less complex to capture the potential effects and consequences. This is why the activities developed at this step have to provide the necessary analysis and evaluation regarding the associated scenario before setting the decision that will be submitted for approval. The decision approval step consists in submitting the pre-selected decision to the decision approval board. This approval process can vary from a simple adoption or rejection vote to the development of a more complex workflow, leading to decision adjustment to get the approval of all parties. During this approval negotiation step, extra analysis on the decision impact as well as decision adjustments can be made. The decision deployment is the last step of the decision process workflow. It consists in broadcasting the decision to the actors in charge of implementing it. Some deployment preparation tasks can be added to define exactly the implementation process. All these macro tasks can be achieved by one or several predefined actors. Their associated process can be defined formally to improve the decision process replication and to allow decision tracking. Informal processes can also occur as well as for some tasks or activities. Similar to manual operations, these informal processes are described and tracked simply by identifying the actors in charge of them, their inputs and outputs. But this cannot capture, of course, fully the rules guiding the decision inside this manual process. Before detailing blockchain governance requirements, we must keep in mind that blockchain projects are often similar to open source projects. First, lots of public blockchain use an open source software, so we can consider the blockchain as a particular instance of open source software. Open source software development often rely on voluntary contributors and users, establishing a community sharing the same product development vision. This collective action during the software development step leads to a collective innovation process. Regarding governance, at this step there's a community enactment, and the latter refers to a spontaneous governance. At this step, members join more or less freely the community, and there's mostly informal interactions between contributors. The software product development grows while extending its community of users and contributors. At this implementation step, informal interaction rules are no more sufficient. This leads to establish rules to organize internal interactions and community management. This leads to set up internal governance to organize a distributed community. Lastly, when the software product reaches maturity and its development is more or less stabilized, the associated community is institutionalized and interaction with external parties are regulated thanks to new governance rules. Focusing on the open source software governance strategy, Red Hat identifies different modules. First, the initial community is often regulated by a simple rule. Who works on the project can participate to the decision. It means that people get authority from the job they achieve related to the time investment they made on the project. It may be difficult to join the community, showing that you got a real competency to achieve the job properly. Second, the initial contributors, the funders, manage and have a fully control on the project. Their decisions are related to the project vision, to core modification, and it can also impact the community organization. deciding who can join the funding set or not. Third, for larger projects and communities, it may be difficult for a reduced set of individuals to manage the community and the project development, keeping its consistency and making the appropriate strategic evolution choices. To this end, different groups can be associated to the different kinds of decision. This is a way to share and organize formally the governance. Fourth, governance can also be set as a democracy. Voting activities can be set to approve the way the decision organization is set, to approve changes, to approve everything. This involves predefining who can vote and who can submit a proposal for votation. In such case, the votation parameters needs to be clearly identified. Is it the full organization or not? The full project, all decisions, or not? The last two modules, corporate-backed and foundation-backed, refer to more classical governance organizations. In both cases, the open source software project is managed by companies or a foundation in charge of organizing the development and managing the project life cycle. Identifying the blockchain governance perimeter is heavily related to the blockchain ecosystem. As seen in Lecture 3, a blockchain ecosystem is not limited to technological components. It gathers multiple complementary and sometimes competing actors. Moreover, due to the variety of potential usages of expected benefits, partners and blockchain users may have different priorities. Setting a consistent governance aims at regulating the partners' and users' interaction to achieve a common and consistent objective, even if they have different priorities. Governing the blockchain involves setting different internal regulation rules accepted by all parties to manage decisions regarding the technical implementation, evolution, blockchain operation, as well as tactical and strategical development of the blockchain ecosystem, including the regulation of the blockchain ecosystem evolution. So, let's first investigate the way the blockchain ecosystem is organized to identify the characteristics of the decision and governance organizations. Similar to open source software communities, we can split the ecosystem into two main groups. Core members are those involved in the blockchain business definition and operation. They include leaders, those who create the project and invest to support it. As a consequence, they are the major beneficiaries of the system if the system successes. Consequently, these members can fix the tactical and strategical vision of the system. Core active members control and optimize the operation activities and manage the community. As a consequence, they are mostly concerned by operational decisions. Active members are primary participants and can contribute to the governance workflow. Peripheral groups consist in users who can benefit from the blockchain project, manage their own data, but they are not involved in the blockchain governance. Service providers who bring support services or usage-oriented services for the project are also members of peripheral groups. Their contribution is connected to the blockchain project, but they are not involved in the blockchain ecosystem governance. To identify the role each party plays in the blockchain ecosystem, we define two classes of activity: technology-related activities and usage-oriented activities. Technology-related activities are developed by the core developers according to the requirements set by the leaders or core members. Developments refer to the core blockchain structure and governance workflow. Block validators, miners, are in charge of the block validation activity. Support service providers may be managed by dedicated actors focused on the operational infrastructure. Usage-oriented activities are mostly defined by investors who agree to finance the project. Usage-oriented service providers can develop value-added services so that the blockchain catchment area can be improved. Lastly, users pay directly or indirectly to get the blockchain services. They can accede to their own data but are not involved in the organization governance. Let's focus now on the way the blockchain organization is set. As seen in previous lecture, distributed organizations are set either in a centralized or in a decentralized way. At the operation level, blockchains have been designed to support peer-to-peer trusted transactions. There is no trusted party to certify the transaction. Trust is provided by the distributed replicated ledger, which provides an immutable trust of the peer-to-peer approved transactions. Compared to traditional transaction authentication organizations, blockchain appear as a decentralized implementation of the validation process. But does this decentralized ledger implementation mean that the blockchain is organized in a decentralized way? In fact, the ledger implementation does not reflect the distributed organization of the blockchain system. Each blockchain project and its related distributed organization are designed separately, requiring IT development and infrastructure. This leads to complex distributed ecosystems. As for other IT projects, a blockchain project provides a service that can be used by end users or by other IT components. The initial investments used to support the project development and its infrastructure is provided by initial investors, who may be also some blockchain developers. Similar to production system, a dedicated organization is set and investments supporting the project development are decided, paying attention on the return on investment, showing the profitability of the project. This means that the core active members invest continuously time and even money to maintain the blockchain or to make it evolve according to the current requirements, upgrading or scaling. This may lead to extend the core active members community. To this end, cooptation rules and mechanisms can be set to accept or reject the application of a new active member in the blockchain core community. As this core community shares risks and profits, it is in charge of tactic and strategic decisions. Such decisions are not so formalized as Operation 1. This may require informal off-chain exchanges between core community members to prepare and set a decision for approval, evaluating the potential impact of the decision according to their own objectives. So it means that the blockchain provides a decentralized service but is organized in a rather centralized way. To evaluate the governance perimeter, we propose to consider the blockchain governance according to two main dimensions, the technological dimension and the ecosystem dimension of the blockchain systems. Considering blockchain as a technological object, different kinds of decisions could be considered. Obviously, the trusted block validation process holds a large part in the operational governance. This strategy is chosen from the early creation of the blockchain by the initial investors and the core developers. It impacts the block validator community enactment. In an open organization, this block validation strategy defines the costs and benefits rules associated to the block validation. The block validation can be trusted as validators invest, they pay for the validation. This investment is a guarantee that the job is done properly. As the blockchain integrity and availability is a major stake, threats cannot be ignored. This leads to identify from the early design step rules to manage decisions regarding hacking, how to stop the process, how to isolate the chain, should there be a fork to protect a part of the chain, how to manage induced losses. These are key questions. Operation and tactic decisions regarding core software evolution may also occur to improve blockchain core software efficiency and efficacy, adding some features or correcting some bugs. These kinds of decisions and the decision process must be defined from the early design steps, including the scope of the decision, its motivation, and the decision process, defining who can vote and how votes are counted, and so on. Potential forks must also be considered as the result of the decision process. Considering the blockchain ecosystem rather than the technology, blockchain governance is mostly devoted to control. We have to control the potential usage. This refers to the strategic decision to identify the catchment area and, as a consequence of the catchment area development, to the performance scaling decision. The catchment area is first defined by the leaders who invest for a given project, and other core members can participate to the catchment area development tactical decisions. The way the blockchain community is set and evolve involves that first decisions is related to the distributed organization community. Is it an open or a closed community? How are enrolled parties? As said previously, there are different kinds of members of the ecosystem, each of them having dedicated roles and rights. Core members are in charge of the first strategic decision, closed or open blockchain, for example. They also establish rules for co-opting new core members. We can note that if core members can approve the ecosystem evolution, a reduced set can fix the strategy to manage a core ecosystem. In other words, a leader can decide to lock the ecosystem governance for strategic or tactic decision. As just stated, different kinds of governance rules are introduced. In this part of the lecture, we will present the different decision levels governing a blockchain project before discussing the way they can be implemented as on-chain, off-chain governance processes. Setting blockchain governance can worthily adapt IT governance model. As a technological IT object, blockchain systems share similar challenges with complex IT projects as decision rights, decision accountability management, project incentives, identification, and so on. This leads to identify technology-related decisions achieved mostly by the development community according to the requirements provided by the project founders. They have to pay a particular attention on the way transactions and blocks are validated and defined. As blockchains rely technologically on distributed ledgers, a particular attention must be paid on the way the distributed organization associated to the network community is set and organized. This network governance is in charge of identifying the different roles and rules allowing to join or not a given role, and not the full ecosystem. Nevertheless, blockchain systems are not only technologic IT objects. They are also distributed organizations integrating various communities, providing different services. They are complex ecosystems, as we have said it in Lecture 3. Focusing on the way socio-technical decisions are made, we can note that some decisions are hard-coded in the blockchain protocol. These decisions refer mostly to the blockchain operation, the core block validation process, of course. Other simple decisions can be submitted for approval, for example, allowing a new participant to join the network. These decisions are governed by the infrastructure. They are defined as rules in the blockchain protocol. Of course, this governance by the infrastructure questions the way the protocol is defined, the way the infrastructure is governed. This governance of the infrastructure is first directed by the strategic decisions derived into tactic decisions before being implemented by the developers. Similar to other IT projects, this governance of the infrastructure defines the development strategy, the way development project is coordinated, and the way evolutions are decided and validated. This leads to split the blockchain governance into different governance functions in charge of managing the community, the development, and the operation protocol. Setting blockchain governance can worthily take advantage of IT governance models. As a technological IT object, blockchain systems share similar challenges with complex IT projects as decision rights and decision accountability management, project incentives, and so on. This leads to identify technology-related decisions achieved mostly by the development community according to the requirements provided by the project founders. The development community has to pay a particular attention on the way transactions and blocks are defined and validated. This is something different than other IT projects, of course, and specific to blockchain. As blockchains rely technologically on distributed ledger, a particular attention must be paid on the way the distributed organization is set and organized. This network community governance is in charge of identifying the different roles and rules allowing to join or not a given role. Nevertheless, blockchain systems are not only technological IT objects, they are also distributed organizations integrating various communities, providing different services. Focusing on the way socio-technical decisions are made, we can note that some decisions are hard-coded in the blockchain protocol. This decision refers mostly to the blockchain operation, to the core block validation process, for example. Other simple decisions can be submitted for approval, for example, allowing a new participant to join the network. These decisions are governed by the infrastructure, which is defined as the core blockchain system. These decisions are defined as rules in the blockchain protocol. Of course, this governance by the infrastructure questions the way the protocol is defined. It means that the way the infrastructure is governed. This governance of the infrastructure is first directed by the strategic decisions derived into tactic decisions before being implemented by the developers. Similar to other IT projects, this governance of the infrastructure defines the development strategy, the way the development project is coordinated, and the way evolutions are decided and validated. This leads to split the blockchain governance into different governance functions in charge of managing the community, managing the development, and managing the operation protocol. Governing a blockchain means organizing a complex decision process to manage several kinds of decisions. First of all, we have to pay attention on the way the key business requirements and their evolutions are defined and managed. These decisions impact the project enactment and its strategy. These decisions define both the provided service, the catchment area, as well as the potential communities that will be set to support and use the new blockchain project. A particular attention must be paid on the project initial scaling and the potential evolution, as this affects directly the block validation strategy. Depending on the number of transactions and blocks that must be validated per second, we will have to tune the blockchain project and the blockchain infrastructure. These business requirements are then turned into system specifications to manage the required development projects. Focusing on the core blockchain technological choices, the way blocks are validated and stored are key technological decisions. These decisions related to the block authenticity are heavily connected to the business requirements, leading to define the validation protocol. At this step, we need to choose the proof of work, the proof of stake, the reputation-based protocol, according to the strategic choices regarding the validator's community management. We have also to pay attention to the target quality of service associated to the block validation. This conditions the blockchain scaling ability. At other IT projects, core development may evolve, managing bug correction, improving code performance. This leads to new versions. As the new release may impact the previously validated blocks, core development evolution must be negotiated and decisions must be taken collectively, especially when they lead to a hard fork of the system. Paying attention to functional risks, we can note that due to the block validation delay, ownership dispute may occur. But what is an ownership dispute? In fact, people can listen blocks to be validated. This allows access to public but not yet validated transactions. As far as payment transactions are concerned, this means that this payment can be redirected to other accounts by proposing a new transaction with much higher validation fees. Organizing processes to solve these ownership disputes is a key issue for safe transaction management. This may also involve transaction reversal processes to restore ownership. The intrinsic blockchain corruption risk cannot be neglected, as trust depends on the block validation process. In fact, when enough malicious block validators corrupt the blockchain itself, this Byzantine fault cannot be corrected immediately. It requires a hard fork or a transaction reversal mechanism as well. So, based on these key decisions, setting a consistent blockchain governance involves identifying precisely the blockchain project scope and context, to pay attention to the strategic and tactic aspect of the project, the blockchain community organization, paying attention to the different rules, incentives to develop the community and the membership rules, fitting the project strategy, and the blockchain decision system, paying attention to the way actors communicate and to the way decision processes are set. There are different strategies to implement blockchain governance functions. On-chain governance refers to decisions that can be managed online. These automated decisions are derived from the blockchain protocol. They include the registration of a validated block, the implementation of the block validation reward mechanism, the management of the voting mechanism to approve a submitted decision, for example. We can note that setting a voting mechanism is not so simple, as the protocol must define rules to define precisely who can vote and the precise ways of each vote. As these decisions are precisely described, the decision process is well formalized and fully transparent. Nevertheless, only simple decisions such as approving or rejecting a proposal, even if the proposal is complex, can be managed online. As we've seen previously, tactic and strategic decisions are more complex and may use uncertain information. This leads to such an off-chain decision system. Actors involved in the blockchain community can take advantage of formal and informal relationships to exchange information, negotiate, to prepare a decision. So this means that people have to reach a consensual position. We can note that this decision process may include discussion, negotiation, voting, and even legal dispute before reaching a consensus. As most of these processes are informal and may require time, may require different experts, off-chain governance decisions may lack of transparency. While the blockchain ecosystem grows, mixing on-chain and off-chain governance can be seen as an opportunity to develop blockchain democracy. It takes advantage of the off-chain informal process to prepare decisions and then to transparently submit them for voting according to the on-chain governance protocol. By this way, off-chain negotiations can occur while preparing complex strategic and tactic decisions, evaluating the different choices. Then, the different actors of the blockchain community can take a part in the collaborative governance by voting to accept or refuse the submitted proposal. When initiating a blockchain project or intending to use an existing one, it is important to understand the way a blockchain system governance policy is set, either to create an adapted governance policy or to integrate the blockchain governance policy as a criterion to decide whether or not to participate in this blockchain project. As mentioned previously, the governance policy is heavily coupled to the blockchain ecosystem management and to the blockchain project development strategy. Strategic and tactic project decisions are reflected in governance rules. These rules are set and their evolutions are controlled by a reduced community, mostly the project owners, that are initial investors and or founding developers. But how can we describe this blockchain governance policy? To this end, we introduce now a blockchain governance framework to ease this policy description. Creating a blockchain project involves defining precisely who owns the project and rules regulating this project's owner's community. Integrating an existing project questions also for project ownership in a similar way as integrating open source code in an IT project. It is necessary to evaluate the impact of any changes in the blockchain system governance on the IT system using it. Focusing on the project lifecycle, a particular attention must be paid on the way the ecosystem is organized and developed, which incentives are used, how participants are recruited, how can they take part in the ecosystem operation and decisions. This leads to provide adapted answers to key decisions listed in the governance challenges. But how can we guide this governance policy enactment or this governance policy analysis? To guide the enactment of a blockchain governance policy or the evaluation of the governance practices of an existing governance ecosystem, PELT has proposed a blockchain governance framework. This blockchain governance framework is inspired by enterprise architecture and IT frameworks introduced to industrialize IT development. This blockchain governance framework manages different governance dimensions related to the blockchain community organization and to the on-chain off-chain decision organization. Defining the project scope and the precise context is the base of the module. Then the governance system is defined integrating on-chain and off-chain governance. Focusing on the decision scope, Off-chain governance is split into two subcategories in charge of governing the ecosystem and the software project development. For each type of governance, key decisions are identified according to two main categories of governance function: governance related to the ecosystem management, defining roles, incentives, and memberships, and governance of the decision process, paying attention to the way actors communicate and to the means used for that. In what follows, we detail the different parts of this framework. Key questions used to define the blockchain project formation and context are first related to the identification of the blockchain project perimeter. The project field and the precise value-added services are defined precisely, as well as the catchment areas. The project perimeter specification is necessary to identify the potential users and the project scaling constraint. By this way, regulation and quality of service constraints will be taken into account while choosing the appropriate protocols. The blockchain system organization is heavily related to the initial project organization strategy. Identifying the project owners and its formative ideology is necessary to capture key decisions such as the way investments are made, for example, which investors participate to the decisions to define the software licensing model or the way the ecosystem will be managed. Focusing on the ecosystem off-chain governance, questions are set to capture the ecosystem community organization. First, borders are identified by questioning the community organization in terms of roles, of relationships between these different roles, and questioning for accountability checking. Second, community development refers to the development of incentives, paying a particular attention to the monetary and non-monetary rewards, encouraging actors to join and actively participate to the ecosystem. Lastly, membership definition allows defining community borders as well as identifying rules to allow a new actor to join the community and play a given role. The way the ecosystem decision process is reported is also important. This involves paying attention to the way participants communicate, identifying the media they use to support community discussion and achieve an agreement. These questions allow identifying formal and informal exchanges between members, understanding the way the decision system is built. Key decisions impacting technical choices are also considered, paying attention to functional risks such as ownership disputes resolution or signaling systems. As blockchain is a software-supported technology, governing this blockchain system involves paying attention to the way the software development is organized and managed. The development community organization must be defined precisely, including the different roles, the hierarchical relationships, and the responsibilities. The identification of incentives depends on the developer's status that may be hired or paid for the development, and this is opposed to the volunteer contribution leading to rewards or funding arrangement. This organization is central while defining the project ownership. It impacts the source code licensing model, the source code access control, and so on. This organization impacts the project modularization and the global strategy to ease or not the integration of new developers. Focusing on the development decision process, key tactic decisions are related to the release validation to hard fork that may need negotiation, of course. Other development decisions are focused on the way conflicts are managed, on the way decisions are prepared and implemented. This development community decision system is also supported by key communication functions supporting development discussions, coordination, tracking development tasks to maintain the system consistency and transparency. Focusing on operation governance, on-chain governance rules are set in the blockchain protocol. Regarding the community operation governance, the protocol defines different rules to control participant admittance conditions. Voting mechanisms can also be set to control additional nodes. Different roles that may be organized hierarchically are also set to manage participant access rights and the associated responsibility area. The protocol implementation also integrates participant incentives, monetary or non-monetary rewards mechanisms to ensure the community development. Focusing on the decision system, communication media can be used to allow informal communication between participants in order to exchange information before voting. Communication channels with other layers are also necessary to manage system evolution. Focusing on the core operation decision, the consensus mechanism is hard-coded in the protocol as the core of the blockchain system. Voting mechanisms can be set to accept or reject a software evolution proposed by the development community. Decision process regarding potential conflicts can also be defined to manage them efficiently. So, after presenting blockchain governance organization and principles, then presenting briefly the PELS blockchain governance framework, it's now time to conclude. Governing complex socio-technical systems, such as blockchain, involves defining adapted rules to control both the IT technological side of the blockchain system and the associated ecosystem. As an IT system, blockchain technological governance is rather similar to other IT system governance, paying attention to technological choices and to its socio-technical impacts. This IT governance also fits well the blockchain software development requirements. As a distributed organization, blockchain governance is in charge of developing and managing the different communities involved in the blockchain ecosystem. These governance functions are split into off-chain and on-chain governance. Either precisely formalized in the blockchain protocol or relying on informal exchanges between ecosystem members, these governance functions can be designed and analyzed thanks to a multi-dimensional and multi-layer blockchain governance framework inspired by the traditional enterprise architecture frameworks. This lecture has been based on several resources, such as books, papers, conferences, and few internet links. Each internet link, as stated in the lecture notes, has been tested till fall 2022. Thanks for attending the Erasmus Plus CHAISE Module 2 Lecture 5 on Blockchain Governance lecture. We can get in touch using the CHAISE social media website and so on.